Good morning, everyone. I am Dr. Manali Choudhury, and today we are going to talk about something which is a little different from what we have spoken so far on this channel. Today, I want you to first imagine one simple question. If humans disappeared tomorrow, would energy generation on Earth stop? The answer is no. Forests would still harvest sunlight, oceans would continue to circulate energy, and creatures like electric eels would still produce voltage. Now, today I'll make a short but important argument. Green energy isn't only urgent. Nature already provides the blueprints for solutions we urgently need. Our focus is bio-inspired energy systems, learning renewable power from plants, animals, and ecosystems. Now, fossil fuels still supply the majority of greenhouse gases. India's electricity emissions are very large, and global energy demand will keep rising. But here are two facts many don't realize. First, Earth receives roughly 1,73,000 terawatts of solar energy annually. We use only a tiny fraction. Second, a large part of renewable inefficiency is design related. We lose energy by ignoring how nature stores and channels energy. That's the opportunity space for bio inspired design. Now, biomimicry or bio inspired engineering studies organisms and ecosystems to solve human problems. In energy, this means copying how leaves collect light, how termite mounds manage heat, or how certain organisms store or generate electricity. Unlike a novelty, this is an engineering discipline, mechanistic, testable, and scalable. Now, chloroplasts in plants root and convert photons with remarkable internal efficiency. Our best silicon panels average around 22% conversion in practice. Plants do the circuitry differently and avoid waste. Engineers examined sunflower phyllotaxy, the spiral packing, and created past solar trackers that mimic geometry. These trackers can increase harvest by 40% without complex sensors, motors, which are there in the man-created panels. Now in India, the solar tree concepts models the branch patterns to stack panels in a small footprint, saving and improving access. Termite mounds are masterful passive HVAC systems. They maintain nearly constant internal temperatures through networks of vents and convection channels. Architects have used the same principles to design buildings that cut cooling energy dramatically. Case studies show buildings that use up to 90% less mechanical cooling. The lesson: part of green energy is using less energy through better design. Researchers have transplanted bioluminescent proteins from organisms like jellyfish into plants. Results are early yet promising. Plants have been engineered to glow for hours. Imagine pathways, parks, or interior accents that provide low level lighting without grid electricity. It is not a replacement for high lux street lighting today, but as a niche, decentralized lighting solutions, it could save energy and provide resilience. Now, electric eels generate large voltages using stacked biological cells that move ions in specific ways. Engineers have copied these ionic channel arrangements to create flexible, biodegradable biobatteries that can function in saline environments. The potential application is compelling, cell powering medical implants that do not require battery replacement surgeries or biodegradable sensors, and they in turn reducing both patient risk and electronic waste. Algae can produce oil eels far higher than terrestrial crops can and grow in wastewater. So they won't compete with food or arable land. Some strains also produce electric currents through photosynthesis. There are reports, though they are small scale, of microprocessors being powered for months by algae produced cells. Algae systems can therefore combine carbon dioxide and wastewater treatment and energy production. A true benefit that suits rural and distributed energy systems. Now, India is well positioned in this context. Rapid solar growth, significant biofuel potential, and active research in bio inspired designs, institutes, and research councils are piloting solar trees and biobattery concepts. Algae based rural systems are being researched for off grid electrification. The takeaway from these aren't only foreign curiosities, they can be adapted and scaled for Indian contexts too, particularly in rural, microcosmic, campus research, and health technologies. In closing, nature is not just beautiful, it is supremely efficient. Our challenge is to learn from ecosystems and apply their strategies to reduce demand, harvest energy smarter, and design biodegradable local solutions. If we pay attention to leaves, mounds, eels, and algae, we find blueprint for a sustainable energy future. Thank you.